Hello everyone, this is Sangeetha, Assistant Professor, Electronics and Communication Department, SNS College of Engineering, Coimbatore. So in the last video we discussed about the basics of image enhancement and histogram equalization. So in this video we are going to discuss about histogram equalization and matching. So in the last video itself I have told the basic things about image enhancement. So let us recap the previous video. So image enhancement is a process of improving the quality of an image. So the main goal is to make certain features more visible, and there are two domains, and we have seen the applications of image enhancement, that is medical imaging, satellite imaging, and photography. So these are the some applications of image enhancement and histogram processing. So first we will see what is histogram. So histogram is a graphical representation of the distribution of pixel intensity values in an image. So it shows how frequently each intensity value occurs, so which provides insights into the image contrast, brightness and dynamic range. Using this histogram we can analyze this type of information like contrast, brightness and dynamic range. So in histogram equalization, there are here I have shown image histogram slicing. So in this image, the x-axis represents the pixel intensity values, that is gray level in an image, and y-axis represents the number of pixels in the image that have each intensity value. So types of histograms, that is grayscale histogram and color histogram. And the grayscale histogram displays the intensity distribution of grayscale images. Grayscale means a single channel. Color histogram displays the intensity distribution of each color channel, that is red, green and blue separately in an RGB image. So in let us see how to interpret a histogram. So low contrast image, a histogram that spreads across the entire range from 0 to 255 indicates a good contrast. The histogram is skewed to the right side, that is bright image. The histogram is skewed to the right side image, that is it is shown in the figure C. And dark image, the histogram skewed to the left, it is shown in figure B. And balanced image, the histogram has more even distribution across the entire range. So this is the basic of histogram. And histogram techniques, there are two types of histogram techniques. One is histogram stretching and another one is histogram slicing. So histogram slicing is a technique used to highlight certain intensity ranges while suppressing others. And histogram stretching. So histogram stretching or contrast stretching is used to improve the contrast of an image by spreading out the pixel intensity value over a wider range. So the main process involved in this process are the pixel intensity values of an image stretched to cover the entire range of the histogram, that is from 0 to 255. So if an image histogram is concentrated in narrow range of intensities, it will look dull or low contrast. So the histogram stretching redistributes these values to use the full intensity range, improving contrast. So the main step, there are some steps involved. The first step is find the minimum and maximum pixel intensities in the range, and the next step is rescale the pixel values between 0 and 255 using a linear transformation. So the formula used here is I minus I minimum divided by I max minus I minimum into L minus 1, where I dash is a new intensity, I is the original intensity, and I minimum and I max are the minimum and maximum pixel intensities in the image. L is the maximum intensity level, that is 255 for an 8-bit image. So the main effect of this histogram stretching is it increases the contrast by spreading the intensity levels over a larger range. It is ideal for images with poor contrast where intensity values are concentrated in a narrow band. The next one is histogram histogram slicing. So the histogram slicing is a technique used to highlight certain intensity ranges while suppressing others. This is powerful when we want to focus on a specific part of the image based on the intensity. So the main processes involved in this are: a certain range of intensity is sliced out and the pixels within the range are either enhanced or highlighted. And the next process is the remaining intensity value inside the selected range may be suppressed or set to a specific value, for example black. So there are main steps. First we have to select a specific intensity range to highlight and enhance, that is we have to assign new values to the pixels within this range, and the last step is set the rest of the pixels outside this range to a lower intensity value. So the effects are that it emphasizes the particular range of pixel intensities which can be useful for extracting specific features in an image. It can be applied to isolate specific elements from an image, such as separating a bright object from a dark background. The next one is histogram matching. The histogram matching, it is otherwise called as histogram specification. It involves transforming the histogram of one image to match the histogram of another image. So this is useful when we want to two images to have a similar appearance in terms of brightness and contrast. So the main goal is to modify the intensity values of the input image such that its histogram matches a predefined histogram. So there are some steps involved in this process. The first step is, first we have to compute the histogram of the input image and the reference image. So then compute the cumulative distribution function, that is CDS, for both histograms. And the final step is to apply a transformation to map the pixel intensities of the image to the input to match the CDF of the reference image. So it will make two images visually similar, and in terms of contrast and intensity distribution, it is widely used in image normalization and processing, such as when aligning different satellite or medical images for comparison. So this is the example image for histogram equalization. So I hope this video will help you to understand what is histogram stretching, what is histogram slicing and matching. Thank you.